Today we're here at a North Florida power plant. It's a coal fire plant, and we're dredging out a surge basin. All the produce waters from this coal fire power plant come untreated into the surge basin where we get sedimentation buildup. We have Encore dredging with a IMS 4010 dredge. They're pumping 2,000 gallons per minute of slurry from the surge basin to Geotextile tubes delivered by GSI. We're using Mast Environmental Solutions Mast 126 to facilitate an inline flock and dewatering in the geotextile tubes. And the clean filtrate water coming off the bags is going back into the settling pond.
Our objectives were actually threefold. We had a project related to cleaning out the drying beds, the material that had to be hauled off to a landfill. We had a project of dredging and pumping settling pond material to the drying beds. And then we were tasked with cleaning out the surge basins. The surge basins being the initial material that comes in from the plant. We chose on this particular project to use the GSI tubes. We had looked at other technologies, including plate and frame presses and vacuum presses. And while the technology has been around a while, we have never really used the GSI bags. And we thought that this was a very good application for the GSI tubes, and we decided to try them out on the project.
We're going to take an 8-inch piece of HDPE. 10-inch, excuse me, 10-inch. So we use these stingers to fill the bags. Gives us some flexibility we can connect to and disconnect from them real quick. We definitely want to have flexibility. These bags, remember, are being filled up. These are 60-foot circumference by 100-foot long bags. You know, in this case, we can fill a 60 by 100 in about an hour and a half to 2 hours. Disconnect from one bag to the next, and we don't have to worry about inefficiencies due to fill time.
Encore's role is to dredge out 2 surge basins and 2 settling basins. We're using geotextile tubes to hold the material in these 2 50 by 180 concrete surge basins. Encore's dredge is a IMS 4010 2002 model, and it's a 10-inch pump, 10-inch pipeline, and it produces about 3,000 gallons a minute of water and about, depending on the material, about 1,500 to 1,800 gallons per minute of slurry. Our dredge is very versatile and get in some real tight spaces. The geo bags have a phenomenal purpose on areas where you don't have nowhere to put the material, you can't dig down. You can put bags on asphalt parking lots and fill them on asphalt parking lots. You know, you can turn any area almost, if you have room to lay out a bag, into a spool basin.
So in order to get polymer makedown started, we turn on water. We need a good flow of water with good pressure. That's first. We get water going through the unit. Verify flow. Polymers on from the tote. We have flooded suction. Once we have power, we have good water flow, we have activation. We turn the polymer up. We've been running somewhere between 18 and 22 gallons per hour of polymer in the neat form. And then again, we're making down polymer at 0.5%, 200 to 1 with water, and activating it here in the activation chamber. This makedown unit works on differential pressure. So it's a differential pressure between the water flow, the polymer being pumped into it, and activation occurs due to that pressure differentiation within the unit between the discharge and the inflow. It unravels the polymer, activates it, and then discharges it through a static mixer into the injection port, into the discharge line of the polymer. And then we have a saddle downstream before the tubes that we use as a sample port, and we can see the inline flock prior to the bags, and we'll take samples there as often as possible before making adjustments back here on the makedown unit. You know, we're looking for good conditioning, which looks like basically like cottage cheese. The solids are all coming together in chunks, and we get good clean water coming to the surface, and we like to see that prior to the bags so that we get that same separation occurring prior to the bags. Solids conditions stay inside the bag and clean water coming off the bag back into the settling basin. We're halfway through our day today. We're on bag number 2 of 60 by 100 GSI Geotextile tube, pumping from the south surge basin. You can see we're about 4.5, 5 feet tall after 1 hour of pumping. We'll get this bag up to maximum height for first fill, and then we'll take it offline and we'll start going to bag number 3. And as you can see here on bag number 1, which we filled this morning after about an hour and 15 minutes of dredge time, we're already back down to 4.5, 5 feet tall. And we'll let this bag drop down to about 2 and we'll refill it again before the end of the day. One of the things that we do during the course of a filling operation is walk on the surface of the bags. Helps break the surface tension on the bags and helps facilitate release of water. The other reason we walk on the bags on top is we're looking at the seams. We can feel the void volume inside the bags and see how much solids versus water is inside the bags. And from a safety perspective, it gives us a good perspective of how the bag is filling, where the pressure areas are, where the soft areas are, where the water is escaping, and where the solids are depositing. It just gives us a good overall perspective. Now that the bag's about 3.5, 4 feet tall, you know, we got a little bit of tension on the bag. Bag's starting to pull up a little bit and together. And it's starting to open up and starting to really push out a lot of clean water that's accumulating inside the bag. So filtrate, water coming off the bags, and this is the slurry, dredge slurry, the material in line prior to chemical conditioning and polymer addition.
The project objectives were met very well. The bags performed extremely well. I was extremely pleased and surprised to actually see the cleanliness of the water that was coming out. Knowing that we were pumping in a slurry containing 25 to 35% solids, and to see that clean water come out was very, very impressive. It absolutely is a viable tool to use for dewatering projects very similar to this. When you have good space and good area to be able to place GSI bags and work efficiently, it is extremely, extremely good to do.